In this session, we want to look at a method invocation. So, as usual, I'll bring up my Java grammar, my JLS grammar. I'll bring up my simplified, hopefully, grammar. Every Java program has to satisfy the goal symbol of a compilation unit. We want to keep things as ordinary and normal as possible. And we found that we could have the keyword class followed by an identifier, followed by a set of curly braces for a class body. And so we're saying that we're defining a class named A1 here, and this is what it's going to do. And in the method body, we found that we could have a method declaration. And the method declaration would have a result type. We used void, meaning nothing. We don't care about the result of this method. The method's name is A1, and it has an empty set of parentheses following the name. And that is key because that is how we can tell a field from a method. Field names will not have parentheses immediately following the name. Methods will. Okay, and so a method declaration could have formal parameters in there. We'll deal with those later, but we've just got an empty set of parentheses right now. Coming up, why? Followed by a set of curly braces, an empty set of curly braces, which was an empty block. So basically that means this method would do nothing, okay, except that it would satisfy the syntax for the compiler. Okay, and we could put some block statements in there, though. So the first block statement we want to look at is a single block statement. And the rule we're going to apply to that is a statement. There's some other things over here, but again, we'll deal with the unusual things later, the less usual. And then we see that the rule for a statement we're applying is a statement without a trailing substatement, which again raises a flag. You're like, if there are statements without trailing substatements, there's probably statements that do have trailing substatements. What would that be like? We'll find out. But for the moment, we're going to say that a statement without a trailing substatement could be an expression statement. Okay? And again, expressions are another rabbit hole, but bear with that. So a statement expression, several definitions for that, but we're going to use a statement expression followed by a semicolon, the semicolon being a terminal symbol. We know that's our statement terminator. So I've got some kind of statement expression and termination of it, the period at the end of the sentence, if you will. So for a statement expression, I'm going to use the rule for a method invocation. Here we go. The rule for a method invocation is a type name, or at least the rule I'm applying, a type name, dot, period, full stop, call that symbol whatever you want. How about we call it a member separator? Because that's what we're doing. We're using it to separate this type name from this identifier, because we know that type names ultimately are going to be resolved to identifiers. So we've got two identifiers in a row. We separate them with a dot. Okay. The identifier that we have here then is followed by a set of parentheses, the terminal symbols there, and enclosed is an argument list. Again, we've got several non-terminals here now. We're going to take the stance of always resolve the first one that we see. So type name can be defined as a package or type name. Okay? And a package or type name can be an identifier. An identifier can be any Java letters and digits we want, so we get to make them up here. But now this is where I'm going to connect to the API. Again, we're trying to invoke a method here. Well, that means that method will have already had to be declared. So where are we going to get a method that was already declared? Well, that's what the API gives us. So bear with me for a moment while I hop over here to the API and say some stuff that may not make a lot of sense. But the API is organized in modules. And modules then consist of packages, and packages consist of classes and interfaces, but we'll deal with that later. So we find that here are the modules in the standard library we call the Java API. And the most basic module, the simplest one, most maybe important one, or mostly used one, is java.base. So if we look at the java.base module, we can see the packages that it consists of. So again, this is an organization hierarchical thing. Think of modules as containers that can hold packages, which are also containers. And we find that one of the packages in the java.base module is java.lang. And again, this is probably the most common, simplest package within Java. And it's automatically available to us. It's the only package that is. Every other package, if we want to use something that's in one of these, we're going to have to explicitly call it out. But java.lang, anything in here is just automatically available to us. The compiler is nice enough to import that, bring it in for us automatically. Okay, so when we look at the when we look at java.lang package, we find that there are a number of classes and interfaces in here, and one of which is, hopefully, we're going to find system here. Yes, system with an uppercase S. Remember, Java letters and digits are uppercase and lowercase. Java is case sensitive. And we find that here is this system class that, again, is automatically available to us, so I can simply say system here. Okay. Now, when we look at the system class, we find the fields and methods that are a part of the class. And we find that one of the fields here, there's 3 fields, error, in, and out, and one of them is out. And so that allows me to say out here, satisfying the identifier after the package or type name identifier here. So I've gotten to out, and then that, according to my rule, is followed by another identifier. And so if I look at the out field in the java.lang package, in the system class, in the java.lang package, we find that it is of the type print stream. So that means there's already another print stream class out there that's been defined, and this field is of that type. It's a reference type. It'll all come together. But if I look at the print stream class, I can find the fields and methods that it is made up of, and we see that in this class, there are a number of methods called print something or other and printlns something or other. Println as in print line. Okay. They haven't abbreviated much else, so I don't know why they abbreviated ln, line to ln, but that's the way it goes in Java. Okay, so now I can satisfy that identifier with println, and I'm specifying system member out member println. Probably the better way to say that. And now I'm down to this argument list. Okay, well, how can I satisfy an argument list? Bear with me on this one. An argument list, one of the rules is an expression, and one of the rules for an expression is an assignment expression and a conditional expression, and we're going to go along, and I will just try to quickly say that if we come back over here to the syntax, and I say, okay, let me find expression. And I want to look for the definition of expression only. So I'm looking for expression on the left-hand side, followed by a colon. And you can see that expression is a big deal in here. So I'm going to narrow this down by saying expression colon, hopefully. Oops, and there it was. So here's expression, which is defined as either a lambda expression or an assignment expression. And so you'll notice I'm choosing the assignment expression. We'll deal with lambdas later. And the assignment expression is defined as either a conditional expression or an assignment. Okay? And I'm choosing the conditional expression. And we find that a conditional expression is defined as either a conditional or expression or this rule or this rule. And now here's another pattern we'll see in grammars frequently. is when you have a long list of possibilities, okay, but they're not repeating. They're all different. How do we do that? And so what we're saying is there's this notion of a conditional expression. And it turns out that this is a syntax actually for a conditional expression. But what we're saying is a conditional expression could be one of these rules for actual conditional expression, or it could be a conditional or expression. So if I go to a conditional or expression, what we find is, oh, it could be a conditional and expression. And then here is the syntax for an or expression. So a conditional or expression would have the two vertical bars, pipe symbols, if you will, followed by some conditional and expression kind of thing. And what that allows us to do is chain these together and say that, okay, I could have a conditional or expression with these vertical bars, and anything that satisfies a conditional and expression, which would be anything that satisfies this first rule. Okay. So a conditional and expression could be an inclusive or expression, or again, here is the syntax if it's actually an and expression. Okay. Inclusive or could be an exclusive or, an and expression, and we're going to keep going for a while. And we'll see down here that the last one I get to is, actually primary is kind of important. Which could be a primary no new array. Oh, it's making me think that there are primaries that do have new arrays, and arrays, whatever those things are, we'll deal with those. But a primary that is not a new array could be a literal. Okay, and we have those basic types, those native types of string, numbers, and booleans, all of which can have literal values. So I want to go with a string literal, and the way that we specify a string literal is by putting it in quotation marks. Okay. A numeric literal, number literal, would start with a number symbol. Again, that's why identifiers can't start with digit symbols. And a Boolean would either be the keywords true or false, but again, I'm going with a string literal here. So I have the quotation marks, the terminal symbol quotation marks, and then I can put string characters, as many as I want, in between there. And a string character is an input character, and an input character is a Unicode input character. So one of the things we see here is that Java understands Unicode. Okay. Now, it's limited as to where you can actually have Unicode. Okay, identifiers, comments, not an identifier. Yes, identifiers, comments, and literals can include Unicode characters, special symbols, as fancy as you want. But the keywords are all plain ASCII characters, which ASCII is included in Unicode, so we're all good. So that gets us to a raw input character, and finally, again, any Java letters, Java letters or digits, Unicode characters, basically. So I chose H, and then I decided, you know what, I'm going to apply this rule up here where I could have more than one of them, and I'm going to include several letters in between there. And now I'm down to all terminal symbols. So I can finally say, let me grab my last one here, copy that, bring that over, paste that into a file where I can save that and bring up my CLI and tell the Java compiler, hey, Javac, why don't you take a look at that file a1.java? And it says, I'm fine with it. I'm good. Okay. Again, still not going to compile yet. We can try it. It won't hurt. Java A1. And we're still getting this message that the main method could not be found in the class A1. So it did find our class called A1, but apparently it was looking for some main method in here, and we don't have it. We have an A4 method, but apparently that's not good enough. We're getting really close to satisfying a method called main, though.